Hello students, myself Mohammad Ashraf, Department of Physics, Seekers Educational Services. So today we are going to talk about electrostatics, okay, basic properties of electric charges, okay, Coulombs Law, electric field intensity and dipole moment. These are some of the things which we are going to discuss, okay, so that you can prepare for your JEE Mains session 2 examinations. So let's start. First of all, electric charge. What is electric charge? Generally, we have seen that from the gravitational chapter that when two objects are kept close to each other, there is a gravitational force in between them, G m1 m2 by r square. Okay, that gravitational force is directly proportional to the product of the masses. It's m1 and m2, and it's inversely proportional to the square of the distance between them. Okay, when the particles were taken, okay, for example, two electrons and two protons were taken, okay, and the force between them was measured when the scientists were discovering these things, okay, they found some anomalous behavior. They saw that the force was not only due to the gravitational force in between them, because we know the masses of the electrons and protons, okay, so we calculated the force due to the gravitational force, but the force which was actually coming what not equal to the gravitational force also. There was some extra forces associated with that, okay, so we came to know that these elementary particles, electrons and protons, they exert another force also, which is the electrical force or magnetic force. So charge is basically that property of a matter of a particle which creates electric force and magnetic forces. Okay. So charge is basically that property which creates electric force. For example, if you keep two charges together, okay, there will be either a repulsion or attraction. For example, if you keep two electrons, there will be a repulsive force in between them. Two protons, there will be a repulsive force in between them, and one proton and one electron, there will be an attractive force in between them. Okay, the force depends upon the amount of charges, how much charge is present. So from where the charge comes, basically, what is the source of charge? So the source of charge is basically the electrons and protons. Since we generally talk about in terms of electrons, because from any matter or from any particle, we cannot remove the protons. The electron is the particle which we can easily remove. Electrons are the particles which are present in the outer orbits of the atom. They are revolving around the orbits. Okay, so we can remove the electrons. Electrons are removable. Okay, they are when the electrons come out. So the electron is the main negatively charged particle, and from the atom where electrons come out, that atom becomes the positively charged particles. So basically, both electrons and protons are the sources of charged particles. Both have equal charge, 1.6 into 10 to the power minus 19 coulomb. Charge of an electron is negative, charge of a proton is same, but it is positive. Both have equal charges, but generally we talk in terms of electrons because electron generally comes out. Protons are well inside the nucleus, they don't come out. Okay. Now, two types of positive charges. Just now I told you, one is positive charge and one is negative charge. Okay, an object becomes positively charged if you remove electrons from there. An object becomes negatively charged if you add electrons in that. Okay. Properties of electric charge. What are some of the properties of electric charge? So first of all, charge is a scalar quantity, as you can see the first point. Okay, charge is transferable. Transferable means you can transfer charge from one object to another object. Okay, if the electrons transferred from one object to another object, okay, negative charge decreases and it increases on the object where the electron is transferred. Charge is always associated with mass. Charge is quantized. This one is important. Charge is quantized. How charge is quantized? If you understand this thing, see, charge q is always quantized. Quantized means it is always an integral multiple of electron, because just now I told you that charge on any object, okay, it comes from either electron or proton. Generally protons don't come out of the atom because they are well settled inside the nucleus. Electrons come out of the atoms. So basically the charge on any object is an integral multiple of electrons. Either on an object there can be one electron, so charge on that object will be minus 1.6 into 10 to the power minus 19 coulomb, or there can be two electrons. So 2 electron means 2 into 1.6 into 10 to the power minus 19, or 3 or 4 or 5 or millions. It means it cannot be like 5.5 electrons. It's not possible that on an object there are 5.5 electrons. So charge will always exist in quantums. Okay, this quantums basically, quantum meaning is, literal meaning of quantum is a steps. So it exists in steps. Ne. This n can be an integer 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 up to millions. Okay, so charge is basically quantized. Charge is conserved. Okay, in an isolated system, total charge does not change with time. Okay, charge is always conserved. Okay, if the total charge is 5 coulomb, it will always remain 5 coulomb. It may transfer from one object to another object, but it will remain conserved. Charge is independent of frame of reference. It does not change with respect to frame of reference. Coulombs law. The most important thing or the most important topic which we have to study in electrostatics, okay, the first chapter of the 12th class, which is Coulombs law. What does Coulombs law say? So Coulombs law basically says that, in a common language, if you want to understand, Coulombs law says that if we keep two charges together, there will be a force between them. Okay, as you can see, if we have two charges Q1 and Q2, there will be a force in between them. Okay, force is either attractive or repulsive. We're not going to discuss about that right now, but there will be a force in between them. Okay, what will be the force? There can be either attractive or repulsive. If the charges have same polarity, okay, if both the charges are positive or both the charges are negative, the force between them will be repulsive force. And if the both the charges are opposite nature, polarity is opposite, for example, one is positive, another is negative, there will be an attractive force in between them. Okay, how much? So it's similar to like of a gravitational force. It is also a central force. What is a central force? A central force is that force in which the force acts between the two particles from the center of one particle to another particle. Okay, and the line of, and the force lies along the line joining the center of one particle to another particle. So gravitational force, Coulomb's force, these all are central forces. So if you take two charges Q1 and Q2, the force between them will be, as you can see here, K Q1 Q2 by R square. K is a constant. Okay, if you see, it is directly proportional to Q1 and Q2, just like the gravitational force. In gravitational force, F is equals to G m1 m2 by R square. G was the constant. Okay, the force was directly proportional to the product of the masses. Here, force is directly proportional to product of charges. If product of charges will be high, force will be high, and of course, it's a central force, so it is inversely proportional to square of distance between them. If we increase the distance between two charged particles, force will decrease. So force becomes K Q1 Q2 by R square. Okay, K value is what? It is 1 by 4 pi epsilon naught. What is epsilon naught here? Epsilon naught is the permittivity of free space or vacuum. Okay, it means this formula is valid for free space or vacuum. Okay, if you keep the charges inside water or inside oil or inside any other medium, the force will be different. In that case, epsilon naught will not be here. Here we'll use epsilon for that particular permittivity of that particular material, water, oil, or anything. Okay, in that case, K value will be changing. Okay, generally almost K value is 9 into 10 to the power 9 Newton meter square per Coulomb square. Okay, so this is basically Coulomb's law, very simple thing. Okay, if you combine all the things which we studied, Coulomb's law means if we have two charges separated by some distance, there will be a force of attraction or repulsion in between them. Okay, the force of attraction or repulsion will be directly proportional to the product of charges. Okay, Q1 into Q2, and inversely proportional to square of the distance between them. Whether force will be attractive or repulsive, it depends upon the polarity of the charges. If the charges are of the same nature, for example, both the charges are positive or both the charges are negative, the force will be repulsive. If the charges are of opposite nature, if one is positive, another is negative, it will be an attractive force. Okay. Coulomb's law in terms of position vector. Very important. Most of these students have confusion in this thing. Coulomb's law in vector form. Okay. So if you see here, it's written as F is equals to K Q1 Q2. We can also write it like R vector divided by magnitude of R whole cube. What does Coulomb's law in vector form is there? Why we need to study Coulomb's law in vector form? Because if you understand the Coulomb's law, okay, from the previous slide, if you see, it was written as F is equals to K Q1 Q2 by R square. Okay, it just gave you the magnitude of force, the direction of force. It didn't give the direction of force. But if you write the Coulomb's law in terms of position vector or in terms of vector form, okay, it will give you the magnitude plus it will give you the direction also. Okay, how can it give the direction? So if you see here, K, Q1, Q2, these things are same as the previous slide. Okay, here we are a little bit changing. Okay, this R is what? This is basically the vector. Vector. Okay, this R, what is this vector? This R is the position vector of force experiencing particle with respect to force exerting particle. For example, if you take two charges, Q1 and Q2, okay, and join them, both are force experiencing and both are force exerting. Q1 is also experiencing force due to Q2, and Q2 is also experiencing force due to Q1, and both are exerting force also. Q1 is exerting on Q2 and Q2 is exerting on Q1. Okay, so for the sake of understanding, we'll assume suppose one is experiencing particle, one is exerting particle. Suppose this is the force experiencing particle and this is force exerting particle. So this R is basically the position vector of force experiencing particle with respect to force exerting particle, and it's R. This is the magnitude of this position vector. Okay, so this will not give you only the magnitude. This will give you the direction of the force also. Okay, going forward, principle of superposition. Okay, what does principle of superposition says? Okay, it may be possible that in a place there can be many charges present. For example, if I write one example here, for example, we have three charges, Q1, Q2, Q3. Okay, distance between them is given. Suppose A. So according to principle of superposition, okay, if you see here, we have three charges taken. There is Q1 also, Q2 also, Q3 also. Okay, and the distance between them is given. So if you take any charge particle, for example, if you take Q1, so on Q1, the force is the electrostatic force. The electric force is not only due to Q2 or not only due to Q3. The electric force on Q1 is because of Q2 also and because of Q3 also. So the net force on Q1 will be the vector sum of force by Q2 and force by Q3, because both are applying force. If you see in a simple language, this one is also applying some force, this one is also applying some force. So basically we can say that on Q1 two forces are acting. Okay, and force is a vector quantity. We don't add vectors like simply a plus b plus c. Okay, we have to add vectors like some. There is a formula for vector addition. If we have two vectors, the addition formula is what? Under root of a square plus b square plus 2ab cos theta. A is the first vector, b is the second vector, and theta is the angle between a and b. If we have two vectors, a, b, angle between them is theta, their sum will be under root of a square plus b square plus 2ab cos theta. Okay, so if you see here on the Q1, there is a force by Q2 also and there is a force by Q3 also. So the overall addition of forces on Q1 we have to calculate how much net force is acting. Okay, so net force we'll have to calculate the force by Q2 also and force by Q3 also. That's why if you see here, F net on a charged particle, it's due to F1 plus F2. There can be more than three charged particle also. So they all will apply forces. So we have to add all the forces, and then whatever force, exact value of force we will get, whatever the resultant value will get, that will be the net force on the body. Why it is called principle of superposition? Okay, we can assume that suppose we have three charge particles Q1, Q2, Q3. Okay, we can assume that there is only two charge particles. For 1 second, leave Q2. Okay, if you leave Q2 for 1 second, force by there will be only Q3. Okay, or if you have to calculate the force by Q2 for 1 second, just ignore Q3. There will be force by Q2. So force on Q1 by Q2, Q3, Q4, it will not be affected by the presence of number of charges. Even if there are more number of charges, it will not be affected if there are many number of charges. Force on Q1 by Q2 will be same. K Q1 Q2 by R square. Force by Q3 on Q1 will be same, even if Q2 is present or not present. Same, K Q1 Q3 by R square. So force is not going to change. Just the thing is the net force on that charged particle will be different because we have to add the forces. Okay, going forward. Okay, there is a question here. There is a particle of mass m carrying a charge q1, as you can see, revolving around a fixed charge q2 in a circular path of radius r. Calculate the time period of revolution and its speed also. Okay, so first try to understand the question. There is a charged particle here, okay, q1, q2, whatever, and there is another charged particle q2 which is revolving around this charged particle in a circular path. Okay, so you may have studied the circular motion. Whenever you come to the circular motion chapter, okay, and if any particle is performing in a circular path, okay, there is some centripetal force acting on the charged particle. Okay, the formula of centripetal force is what? Mv square by r. Okay, and centripetal force is not a new kind of force. Okay, it is basically whenever a particle moves in a circular path, okay, it needs a centripetal force. Someone has to provide a centripetal. It's not a new kind of force. Okay, there is it's provided by different agents. For example, when an electron is moving around a nucleus, the electrostatic force of attraction is providing the required amount of centripetal force. When Earth is revolving around the sun, the required amount of centripetal force is provided by the gravitational attraction. If you take a stone, tie with a string, and then rotate in a circle, so the required amount of centripetal force for that stone is provided by the tension in the string. So it is provided by different agents. It's not a new kind of force. Similarly, in this question, if you see, there is a charged particle Q1 which is revolving around Q2. Okay, how it is revolving? Who is providing the centripetal force? So the required amount of centripetal force is provided by the electrostatic force of attraction in between them. Okay, what is the electrostatic force of attraction? K Q1 Q2 by R square, or also you can write as 1 by 4 pi epsilon naught Q1 Q2 by R square. Okay, now this is providing the required amount of centripetal force. And what is the formula of centripetal force? M omega square R, or mv square by R, anything you can write. Okay, because both it's provided by this electrostatic force, centripetal force is provided by that, so we can write both of them equal. Okay, from there we can calculate the speed and time period. Okay, we can calculate the speed omega value, we can calculate from here. From omega we can calculate v is equals to omega r, and then we can calculate the time period of the rotation. Time period will be 2 pi r divided by the speed v. Okay, from there we can calculate the frequency also. Frequency will be 1 by time period. So these lot of questions can be made from one question. Electric field. Okay, what is electric field? So basically, most of the students have a confusion in between electric field and electric field intensity. In many books also, when they say that calculate electric field, basically they want to calculate electric field intensity. Okay, they are two different things. Okay, electric field is a different thing, electric field intensity is a different thing. Electric field means basically if you keep a charged particle here, Q1, okay, so it means its area, okay, its own territory. If you keep another charged particle, suppose Q2, in its area, this charged particle Q2 will experience a force. So it becomes the field for Q1. Okay, it means its area, its kingdom. If you keep another charged particle in its kingdom, that charged particle will experience force. That's the area. That's the electric field. And electric field intensity is a different thing. Actually, when we study Coulombs law, we study the force between two charged particles Q1 and Q2 separated by some distance r. So it's actually basically a two-step process. It doesn't happen suddenly. It's a two-step process. What happens here? Q1 creates some electric field around it. Q1, when you keep the charged particle Q1, it will create some electric field around it. Okay, that if you keep another charged particle in its field, it will experience force. So what same thing happens here? If you keep a charged particle Q1, it will create a field around it, and if you keep another charged particle Q2, that charged particle will experience force due to the field created by the Q1. Okay, so it's a two-step process basically. Okay, now coming to electric field intensity. So there is a difference between electric field and electric field intensity. Electric field generally refers to the area. Electric field intensity means how much a charged particle can exert force on another charged particle. Okay. For example, we have discussed Coulombs law. Just now we discussed Coulombs law. Force between two charged particles. For example, if we have two charged particles, Q1, Q2, separated by some distance r. Okay. Their force between them will be 1 by 4 pi epsilon naught Q1 Q2 by R square. So this is the force. So this is the force exerted by Q1 and Q2, or Q2 on Q1, whatever you can say. Okay. So this force basically, how did this force came? Okay, I just now I told you it comes from two-step process. You take the charge Q1 and the charge Q2. Okay, the charge Q1 will create an electric field around it. Okay, and as soon as you keep the charge Q2 in its own field, it will experience force. Okay, so that was electric field. Coming back to the electric field intensity. Electric field intensity refers to how much a charged particle, suppose Q1, exert force on a unit charge particle. So basically, it is a force per unit charge. It means force per unit charge. Suppose E is the representation of electric field intensity, F by, suppose Q2, how much it will become? 1 by 4 pi epsilon naught Q1 Q2 by R square into Q2. Q2, Q2 cancel. It became 1 by 4 pi epsilon naught Q1 by R square. Okay, so basically electric field intensity refers to how much a charged particle can exert force on a unit charge particle if it is placed in its own electric field. That is electric field intensity. Electric field due to a point charge. Just now we discussed electric field intensity due to a point charge. So let's assume, okay, there is a charged particle Q. Okay, that charged particle, if you keep another charged particle Q1 or Q dash or Q2, okay, it will experience force how much? 1 by 4 pi epsilon naught Q dash by R square. Okay, if you have to calculate, just now I told you electric field is what? Electric field is basically force per unit charge. In a unit charge, how much force will be exerted? So that is 1 by 4 pi epsilon naught Q dash by R square is the force. If you divide by the Q dash, okay, it will become 1 by 4 pi epsilon naught Q by R square. So basically this is the electric field due to a point charge. Okay, if you take a point charge here, suppose Q, okay, and if you keep another charge here, suppose this one Q dash, okay, with the distance between them is R, force of attraction or repulsion depending upon the polarity of charge will be how much? 1 by 4 pi epsilon naught Q dash by R square. So this is the force exerted between the Q and Q dash. Okay, Q is exerting force on Q dash, or we can also say that Q dash is exerting force on Q. But since we are studying the electric field due to this charge, so we are going to discuss, we are going to say that Q is exerting force on Q dash. So 1 by 4 pi epsilon naught Q dash by R square. So this is the force exerted by Q on Q dash. But suppose here there is no Q dash, there is only 1 coulomb of charge. So how much force will be exerted? In place of Q dash, we can write it as 1 by 4 pi epsilon naught Q. If Q dash is suppose 1 coulomb, so it will become into 1 by R square. So it will become how much? 1 by 4 pi epsilon naught Q by R square, which is same here. 1 by 4 pi epsilon naught Q by R square. This is the electric field intensity due to a point charge. Electric dipole. What is dipole? So basically, dipole is the combination of two charges of opposite polarity. For example, suppose if we have a plus Q charge and minus Q charge separated by small distance. One thing is very clear: small distance. Two charge of same magnitude, opposite polarity. If one should be plus, another should be minus. Opposite polarity separated by a small distance is called electric dipole. Electric dipole. Okay, dipole moment is a different thing. Okay, this is electric dipole. Okay, two charges separated by small distance of opposite polarity, that's called electric dipole. But we have another term called dipole moment. Dipole moment. So dipole moment is a different thing. Dipole moment is basically a vector quantity. Vector quantity. Okay, any vector has two things. Okay, it has a magnitude and it has a direction. So it will also have a magnitude and it will also have a direction. Okay, magnitude of this vector of this dipole moment is how much? Charge into distance between the two charges. This distance, suppose if it is d, so it will become q into d. And what will be the direction? Direction will be from negative to positive charge. From the negative charge particle to the positive charge particle along the line joining the two charges. It means along the axis of the dipole. So what we studied? We studied that electric dipole. Okay, it's basically a thing which is made up of two charges, one positive, another negative, separated by small distance. Small distance is very important. Okay, it can be big distance, but that will not be called a dipole. Okay, for a dipole, the condition should be that it should be small distance, two charges separated by a small distance, plus q minus q, same magnitude, opposite polarity. That is called electric dipole. Dipole moment is a different thing. Dipole moment is basically a vector quantity. Okay, it has two things, magnitude and direction, as like other vector quantities. The magnitude of this vector quantity will be charge multiplied by the distance between them, and the direction will be from negative charge to positive charge. Okay, so these are some of the basic things which we discussed. Okay, hope we'll meet in the next class. Thank you.